All right, so let's look at the next one. So a sample of a radioactive isotope had an initial mass of 840 milligrams in the year 2010. It decays exponentially over time. A measurement in the year 2014 found that the sample's mass has decayed to 340 milligrams. What would be expected mass of the sample in the year 2020? So again, it gave us an initial value. It gave us this initial mass of 840. Which is pretty handy because we can just plug that in. You'll see in a minute that a lot of times, sometimes we don't have an initial value. So we have to find it from 2 points. But if you think about this, y equals ab to the x. If I said, okay, the value was 840 when time equals 0, which is the initial, well, b to the 0 is 1. So that makes A equal to 840, which we already knew. We already knew that that's the way it works, that that's our initial value, but this helped us really understand that why that's A. Okay, so we're going to put that in for A. So we have y equals 840 b to the x. Now again, we have this b, we don't know the rate, but we do have a point on our graph. In 2014, we had 340 milligrams left. So that's a point at time equals 4, because that's 4 years from 2010. Y, or our output, is 340. So we end up with 340 equals 840 b to the 4. We divide both sides by 840. We get b to the 4th equals 340 divided by 840, which is 340 divided by 840, 0.04047. And then we're going to take the 4th root of that again, so we're going to go to the 1/4, and we're going to get 0.7976. So b equals 0.797627 and some change. Okay, so here we have our b. That's our rate. It's growing or decaying at that speed. So now we need to figure out what's going on in 2022. Well, how many years is that from our initial sample? Our initial sample was in 2010, so this is 12 years from then. So we have y. Ooh, that's ugly. All right, y equals 840, and then whatever this b is, right, I'm just going to plug that in right here to the 12th. Okay, and I already have that b in my calculator, so I'm not going to retype it or round it or anything like that. Okay, and then we multiply that by 840, and it says 55.702 or 703, depending on if you round or truncate, 55.702 milligrams. So that's how much is left of the isotope after 12 years. Okay, I'm going to skip over the rabbit population one. So a lot of times we actually don't even have an initial amount, though. You know, we have these 2 different points that are on this function, and we have to figure out what the function is. And this happens not just in exponentials, this happens in a lot of functions. We do this all the time where we say, like, there's some function, you know, and it goes through these 2 points, find the function. So we're going to do that. Okay. So remember, our basic exponential function is y equals a b to the x. And so we have 2 different points on this function. We have when x equals -1, y equals 5/4, and when x equals 2, y equals 80. So what I can do is I can just plug these points into the function, and I can say I know that when x equals -1, y equals 5/4. So I just plug them in for x and y. And I can say when x equals 2, y equals 80. I'm like trying to say them. Yeah, I'm like writing y while I'm saying x. It's not working very well. Okay, so I have these 2 things, and I know both of these functions are true for some a and b. The a and b we don't know. And so now I have what we call a system of equations. Remember, we have 2 equations with 2 unknowns. So we have two different equations that each, we have A and B that we don't know. And the way we can solve systems of equations is by elimination. Just by elimination, okay? So we're going to do elimination, oh my gosh, why did I say elimination? It's substitution. I even thought that in my head. Substitution! I made such a big deal about it. Then I did it wrong. It's substitution. Even geniuses like me make mistakes. You're welcome. So substitution is what we're going to use. Okay, so that means, remember, we substitute one function into the other function. Okay, so we have this one right here, and we know that we could rewrite this so that we can actually find what A equals, right? We don't want to have to solve for B because that takes square roots and crap. So we're going to solve for A. So to get A all by itself on one side, we're going to divide both sides by B squared. So we have A equals 80 divided by B squared. So now we know that A in both of these equations equals 80 over B squared. So anywhere there's an A, I can put 80 over B squared. So I come back over to this one and I have 5/4 equals, and then I put in, instead of my A, I put in what I know A equals, which is 80 over B squared times B to the -1. Okay, so now that I have this, I can say, I can just combine it. Now, this would be 5/4 equals 80 over B squared times B, because B to the -1 is the same as 1 over B. Same thing, right? All right, so I have 5/4 equals 80 over B cubed. And you're going to be tempted to cross multiply here, and I would caution you against it because cross multiplying, just like, there's so many mistakes that happen when you cross multiply. So like, if you really think you can do it, but most of the time people cross multiply wrong and they cross multiply when they can't. So we're just going to multiply both sides by B cubed so that we can get that out of the denominator. Okay, those cancel out, and we now have B cubed times 5/4 equals 80. And then how do we get rid of a fraction? Well, we multiply by its reciprocal. So 4/5 and 5/4 are going to cancel out, and we're going to have 80 times 4/5. So we have B cubed equals 80 times 4 over 5. Now 80 divided by 5 goes in one time with 3 left over, so 16. Okay, so that's 16 times 4. So that's B cubed, that's 64. Yes. Yes. 64. And then we can take the cube root of both sides, or again, raise it to the 1/3 power. Those are the same thing. B equals, what's 64 to the 1/3? It's 4, because 4 cubed is 64. Okay, so now we found B. Whew! Now let's find A. Well, what is A? We came back up here. If we look, A equals 80 divided by B squared, right? Well, and what's B? B's 4. So A equals 80 divided by 4 squared. So A equals 80 divided by 16, which is 5. Okay, finally, we can go back here and we can replace our A and B with the values that we found. So we found that A equals 5 and B equals 4. Now again, everyone's going to be tempted to be like, oh, that's 20 to the x. No, 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 no. Exponents are stronger than multiplication. So 4 to the x times 5. So we do the exponent first. Okay, so here we go. This tells us a point, or a function that has both of those points on it. If you put in -1, you would get out 5/4. If you put in 2, you would get out 80. All right, let's take another look at another one of these. All right, so here's an exponential function that follows this criteria. Let's see. Oh yeah, we're doing good on time. My little timer, there it is. It wasn't showing in the corner, and I didn't know. I only have like 15 minutes per video. Okay. Anyway, now I just wasted 10 seconds talking about that. Okay, so it follows these criteria. What does this mean? Well, that means when x equals 0.5, y equals 13. So I could just write this as a point 1/2 13. Okay, and this means when x equals 6, y equals 36. So I can write this as 6, 36, right? So it goes through these 2 points. It just means when x equals this, y equals that. Oh, you know, on the last one, I think we forgot to plug back in 3. Didn't it ask for, yeah, find the value when x equals 3, so you just plug in 3 for x there. All right, back to reality. So we have this one. It goes through these 2 points. We need to figure out the function. So we have y equals a b to the x. And so, again, we don't know a and b, but we do know an x and a y, and we know 2 sets of x's and y's. So let's get 2 functions here. So we're going to have the first one is going to be 13. 13 equals a b to the 1/2. And the second one is going to be 36 equals a b to the 6th. So I just put in x and y for each of those. Okay, now I can solve one of these for a so that I can plug it into the other one. Let's solve the purple one for a. So we're going to divide both sides by b to the 6th because we want to get rid of that. So we now have a equals 36 over b to the 6th. So this is important. We're going to keep that. And here in this a, we're going to substitute in that, that value we just found. So we have 13 equals 36 over b to the 6th, b to the 1/2. Okay, now this feels like super challenging because it's like, oh my gosh, what does b to the 1/2 mean? Well, it just means b to the 1/2, right? It means square root of b, but we could just do it as b to the 1/2, right? And we think about, well, what's our exponent rules? Well, if we have the same base in top and bottom, we can subtract the exponents. So we're going to get 13 equals 36 over b to the 5.5. Okay, so then we can, because, you know, 1/2 minus 6 is negative 5.5, and that means it's going to still be in the denominator. Okay, so now we can multiply both sides by b to the 5.5. So I have 13b to the 5.5 equals 36. Then I'm going to divide by 13. I get b to the 5.5 equals 36 over 13. And now I've got to undo that exponent, and now you're all like, I have no idea how to undo this exponent. Well, what would we need to multiply 5.5 by to get to 1? Well, the reciprocal. So we can multiply that by 1 over 5.5. And then those would become 1, and we just get b, right? Okay, so let's do this. 36 divided by 13 to the 1 divided by 5.5. Okay, so I get that b equals 1.20345. Okay, so b equals this kind of nasty, b equals 1.203452. And we know that a equals that to the 6th, 36 divided by that to the 6th. So we're going to raise that to the 6th power, and then 36 divided by that answer is going to be 11.85. So we can get back to this where we say, okay, a equals 11.850. So now I can write my function. Y equals 11.85 1.203 to the x. And I know it looks really ugly, but that's real life. That's what functions look like in real life.